So, hello everyone. So, we've been given a question where we have two masses, one on the surface of the body and the one being a satellite, which is orbiting at a distance of twice the radius, which is given as the diameter of the Earth. So, we take it as twice the radius, obviously, and we need to find the force of gravitational force, in fact, between the Earth and satellite. So, we basically write down the equations of gravitational force for both the masses. So first we take mass 1, which is the mass of the body with respect to the earth, which is given by g m m1 m1 divided by r square, which is being the radius of the earth, and the second equation being between the satellite and the earth, which has also been given by the same equation, but this time we consider the mass of the satellite, and the radius is given as twice the radius right now, so we take it as 2r the whole square, right? And this can be simplified with gm m2 by 4r square, right? Okay, so for the body on the surface of the earth, which is given by g mm1 by r square, can also be written as m1 into gravity, which is the Newton's force of equation. And if we cut out both the mass m1 and m1, we get the value as g m by r square equals to g, right? And this can also be written as g m by g r square, right? So right now, what if we substitute the gm value in the f2 equation with gr square, right? Substituting this equation on this equation, right? So what do we get? We get it as gm substitute as gr square, so we substitute gr square into m2 divided by 4r square, right? And we cut out both the r square values, right? And we get it as g m2 divided by 4 as the f2 equation, which f2 is being the force of attraction between the satellite and the earth. So we can assume the value g to be 10 or 9.8 for that matter. We can actually find it out if you need to, which is we have been given the mass 5 kg and on the surface of the earth producing a force of 50 newton, so we can find f1 is equals to m1 g, f1 being the 50 newton force on the mass m1, mass being the 5 kg, and into g, right? So g turns out to be 10 meter per second square, right? This being the g value, and if we substitute it in this equation, which is 10 into m2 being the mass of satellite, which is 200 kg, divided by 4, which turns out to be 500 newton, which is the force of attraction between the satellite and the earth.